In this video, I'll briefly go over each level available in the Object Attributes folder of the content examples for my GameTools Blender extension. Each folder includes a source directory containing the blend file, the mesh and XML report, and textures. The blend file is especially useful as it lets you inspect the exact settings used for the bake and how the Object Attributes Bake tool was configured to achieve the demonstrated result. Alright, the first folder showcases the ability to provide a custom origin. There's not much to say about it. The custom origin object is treated as a world origin in Blender, with its location, rotation, and scale taken into account. This might be useful in rare cases where modifying the transforms of the object to be baked isn't possible. The second folder demonstrates the ability to bake an object's custom properties, including floats and integers. This can be handy for baking masks and other similar data. The third folder shows how to limit the hierarchy depth using the depth limit feature. This allows you to treat children as if they were part of their parent, essentially acting as a single merged object. Select all objects and click Filter Selection to visualize the result. For example, setting the depth limit to 1 allows only the root object to have direct children, but no grandchildren. As a result, the twig and leaf objects remain selected, indicating they'll be treated as if they're connected to the branch. This can be extremely useful when dealing with complex hierarchies. The next example is a reworked version of Epic's Hilltree Pivot Painter content. It has been rebuilt from scratch to be more readable and beginner-friendly, perfect for studying its internal logic. The multi-root example demonstrates the ability to bake multiple hierarchies into a single object. Here, two separate hierarchies are baked together, and everything works as expected. The next folder contains a textbook Pivot Painter example. Encoding pivots and indices in one texture, and axis plus extent in a second texture as demonstrated in a previous video. The following example demonstrates baking data relative to each object's parent. This may be useful in specific workflows. For instance, by storing an object's position relative to its parent, you can work with smaller value ranges. This may allow you to remap them into a 0 to 1 range and store them in 8-bit RGBA textures with sufficient precision. However, this may also affect how you store indices, since the Pivot Painter algorithm requires a 16-bit HDR texture. One option is to store indices in a separate texture, or bake them in 8-bit as well, assuming you have no more than 256 unique elements in the bake. Remapping is demonstrated in the next example. Indices are stored in their own 16-bit HDR texture, while the pivots are stored in an 8-bit texture. They need to be remapped to their original range using the multiplier and bias values reported by the bake tool. The same applies to the axis and extent texture. The next folder demonstrates a technique that I think was not possible with the original Pivot Painter script. Up until now, we've stored the index of each object's parent in a texture, allowing us to fetch the parent, then the grandparent, and so on using dependent texture fetches, which are relatively expensive. Now, if your hierarchy has a fixed maximum depth, you can bake all relevant indices, parent, grandparent, great-grandparent, etc. into a single texture. This eliminates dependent texture fetches and reduces overall texture sampling. It may not be a dramatic performance gain, but it's a cleaner approach worth experimenting with. Pivots, axes, and extents are still sampled the same way as before. The next example showcases the ability to bake the scale of objects, specifically their scale relative to their parent. That means you're storing how much bigger and smaller each object is compared to its parent, not its absolute scale. Baking the absolute scale is demonstrated in the next folder though. Again, the tool offers a wide range of options. It's up to you to find how to make the most of them, especially when it comes to features that might not seem useful at first glance. The next example is quite interesting. Here we have a bunch of unrotated objects. Each one has a custom property pointing to a different object, like an empty, which is used for baking its position and rotation instead of its own transform. This allows for a kind of target rotation baked as a quaternion. That quaternion is then interpolated spherically to create an animation where each object gradually orients itself towards its target. This idea is taken further in the next example, where each object's rotation is baked as is. Each are rotated 45 degrees relative to its parent. That rotation is then added in the vertex shader, resulting in an additional 45-degree rotation. And this can be applied either hierarchically or independently. The next folder serves as a crash test for limiting the texture width, ensuring everything still functions correctly. No changes are required in the shader for this test. Finally, we come to an example demonstrating pre-baking the indices of the entire hierarchy, as mentioned earlier, but this time into an 8-bit RGBA texture. This is a viable option if the total number of indices does not exceed 256. In this case, 8-bit decoding must be enabled and the pivot painter style encoding must be disabled. The pivots baked into the texture along with the indices are remapped to fit within the 0 to 1 range for 8-bit storage. They are then scaled and biased in the shader to restore them to their original values, just like the axis and extent. And voila, these examples offer a glimpse of what's possible with the Object Attributes Baker tool. Feel free to explore, experiment, and have fun with it.